Section 1.1 is going to look at various angles. First, we need to remember what an angle is. An angle consists of two different rays with the same endpoint. In an angle, the rays are called the sides of the angle, and the endpoint is the vertex of the angle. The measure of an angle is determined by rotating a ray starting at one side of the angle, called the initial side, to the position of the other side, which is called the terminal side. A counterclockwise rotation generates a positive angle measure, and a clockwise rotation generates a negative angle measure. So in our two examples here, we have a positive and a negative angle. We're considering this side CA, that ray, to be our initial side. And we are rotating around in a counterclockwise direction and ending here CB. CB would be considered the terminal side. With this angle, CA is our initial side, and as you notice with this arrow showing, it's rotating in a clockwise direction to CB, which is our terminal side. Since we are rotating clockwise, this is a negative angle. And a little bit of a reminder from geometry, there's different ways that we can name angles. You can name it based on the vertex. So for example, we could call this angle C. We can use three letters where the middle always has to be the vertex. We could call this angle ACB, or we could call it angle BCA. When we're talking about angles, we have four different types of measures of angles. We have an acute angle, which is an angle that measures between 0 degrees and 90 degrees. It's not going to be equal to 0 degrees. It will not be equal to 90 degrees. A right angle is an angle that measures 90 degrees, and we show it in an image by putting the little right angle there in the corner. An obtuse angle is an angle that measures between 90 degrees and 180 degrees. And a straight angle is an angle that measures 180 degrees. A straight angle is just like a line. It goes on in either direction. But we can call that a straight angle also. Then you have two situations. You have complementary angles and supplementary angles. With complementary angles, you have two angles whose sum is 90 degrees. If the sum of any two angles are equal to 90, we consider those two angles to be complements of each other. For example, this angle that is 30 degrees and this angle that is 60 degrees, they add up to 90, therefore we would consider them to be complements of each other. Supplementary angles are two angles whose sum is 180 degrees. And the two angles then are considered to be supplements. An example of that would be 110 degrees and 70 degrees. An easy way to remember the difference between complementary and supplementary angles is that supplementary has two p's in it, whereas complementary only has one p. One p is 90 degrees, two p's 180 degrees. Let's look at our first example here. Example number 1. The basketball pole forms a pair of supplementary angles with the ground. Find the measure of angle BCA and the measure of angle DCA. We see here that the measure of BCA is 3x plus 8 degrees, and the measure of DCA is 4x minus 3 degrees. We're going to add those two angles together and set them equal to 180 degrees, since they form a pair of supplementary angles, and supplementary angles add to 180 degrees. We're going to combine our like terms first. So 4x plus 3x gives us 7x, and 8 minus 3 is 5. And then we're going to have to get x by itself, isolate it. We're going to undo some operations, subtract 5 from both sides. We have that 7x is equal to 175. And then we're going to divide by 7. When we divide by 7, we find out that x is equal to 25. Now, all we have to do is we are going to have to substitute x in to each of our equations to find what the measure of each angle is. The measure of angle BCA is going to be equal to 3 times 25 plus 8. Therefore, the measure of angle BCA is going to be 75 plus 8, which gives us 83 degrees. And now at this point, you have a choice. You could either substitute 25 into 4x minus 3, or you could choose to subtract 83 from 180. Either way that you go about it, you'll end up with the measure of angle DCA, and it ends up being 97 degrees. In all of your math classes up until this point, you've used what they call decimal degrees. However, degrees have the ability to be measured in minutes and seconds instead of being measured with decimals. It's a little bit more precise. It's used more when you're talking about things like navigation, but it is another way to write this. 1 minute, written as 1 with a apostrophe, is a 60th of a degree. Or in other words, we could say 1 minute is equal to 1 over 60 degrees. Or 60 minutes is equivalent to 1 degree. 1 second, written 1 with the little quote, is a 60th of a minute. 1 second is equal to 1/60th of a minute, which is 1/3600th of a degree. Or 60 seconds is equal to 1 minute. And the measure 12 degrees, 42 minutes, and 38 seconds would be how we read this. Example 2 has us adding 2 angles together that are in degrees, minutes, and seconds. Whenever we are going to add with degrees, minutes, and seconds, we're always going to add together the degrees, the minutes together, and the seconds together separately. Then anything over 60 gets reduced. So 51 degrees, 49 minutes plus 43 degrees, 21 minutes. I'm going to add my minutes first. 9 plus 1 gives me 10. 4 plus 2 is 6, plus 1 is 7. So we have 70 minutes. 94 degrees and 70 minutes. However, 70 minutes is more than 60. We need to reduce. 70 minutes is equivalent to 1 degree and 1 minute. 1 degree and 10 minutes. Since 1 degree is 60 minutes, 60 plus 10, that's a better way to say it. 70 minutes is equal to 60 minutes plus 10 minutes. And 60 minutes is equivalent to 1 degree. So therefore, 70 minutes is 1 degree and 10 minutes. We're going to rewrite this, therefore, as 95 degrees. We added this 1 degree to 94 and 10 minutes. Here we are missing minutes. It's 12 degrees, 30 minutes, and 12 seconds being added to 1 degree, no minutes, and 55 seconds. You always have to write in the minutes if they are missing. We're going to write this as 1 degree, 0 minutes, and 55 seconds. It ends up being 30 degrees, 13 degrees, 30 minutes, and 67 seconds. However, 67 seconds is equivalent to 60 seconds plus 7 seconds, and 60 seconds is 1 minute. So 67 seconds is equivalent to 1 minute and 7 seconds. So therefore, we have to add 1 minute to 30, and we get 13 degrees, 31 minutes, and 7 seconds as our final answer. Subtraction. Subtraction works similar. Here we have 90 degrees and 0 minutes, and we're subtracting 23 degrees and 12 minutes. Just like when we do normal subtraction, we have to borrow. We need to borrow a degree from 90 to make this be something bigger than 0 minutes. Therefore, I'm going to rewrite this as 89 degrees and 60 minutes, since 60 minutes is equal to 1 degree. And then I'm going to subtract 23 degrees and 12 minutes from it. 60 minus 12 leaves us with 48 minutes. And 89 minus 23 is 66 degrees. We end up with 66 degrees and 48 minutes. The same thing's going to happen here. However, we are in degrees, minutes, and we have seconds here. We're going to start 180 degrees, 0 minutes, and 0 seconds, minus 14 degrees, 0 minutes, and 1 second. But we cannot subtract like that. We need to change this. We are going to borrow 1 degree from 180. We're going to make this 179 degrees. And then it would be 60 minutes. But we're going to have to take one of those minutes away for the seconds. So I'm going to make this 59 minutes and 60 seconds. 60 minus 1 gives us 59 seconds. 59 minus 0 gives us 59 minutes. And 179 minus 14 is 165 degrees. To convert from degrees, minutes, and seconds to decimal degrees, we're going to take the degrees and leave them the same. And then we know that 8 minutes is 8/60ths of a degree, since there are 60 minutes in 1 degree. We're going to add this to 8 times 1/60th. And then there are 3,600 seconds in 1 degree. So we're going to add 14 times 1/3600th. And we end up with 74 plus 8 divided by 60 gives us 1.13333. We're going to add that to 14 divided by 3,600, and we end up with 0.137. I'm going to round to 3 decimal places, so it's 74 plus 0.137, and we end up with 74.137 degrees. We'll do the same thing here in part F. 46 degrees, and we need to convert 16 minutes to degrees. So 16 times 1/60th plus 68 seconds times 1/3600th, since we're going to degrees. And when we do that, we get 46 point 0.28555. I'm going to round that to 286 degrees. If we're going in the opposite direction, if we want to convert 15.635 degrees to degrees, minutes, and seconds, the first thing we do is we take our degrees. So this first part is going to be 15 degrees. And then we have to figure out what proportion of 60 this 0.635 is. So we're going to add that to 0.635 times 60. And 0.635 times 60 gives us 38.1. So this is 15 degrees, 38.1 minutes. And then we have to convert this 0.1 minutes into seconds. We're going to take 15 degrees, 38 minutes, and we are going to add 0.1 times 60, since there are 60 seconds for every minute. So we need to figure out what portion of 60 is 0.1. And when we do that, we end up with 15 degrees, 38 minutes, and 6 seconds. And the last one, part H, we are converting 34 degrees, 34.817 degrees to degrees, minutes, and seconds. So we leave our 34 as our whole degrees. And then we have to take 0.817 and find out what proportion of 60 that is. So we're going to multiply by 60. We get 49.02. So this becomes 34 degrees and 49.02 minutes. And then we have to figure out what proportion of 60 is 0.02. So 34 degrees, 49 minutes, and 0.02 times 60. And we end up with 1.2. We end up with 34 degrees, 49 minutes, and 1 second. We're always going to round the seconds to whole seconds. So since it was 0.2, we're going to round down or stay at 1. In trigonometry, we deal with angles in standard position often. An angle is said to be in standard position if in a coordinate plane, an angle can be formed by fixing one ray, called the initial side, and rotating the other ray, called the terminal side, about the vertex. The angle is in standard position if its vertex is at the origin and the initial side lies on the positive x-axis. Almost all of the angles that we will deal with in this class have an initial side here on the positive x-axis. Our angle is going to rotate in a counterclockwise direction. It'll end in some quadrant, and we consider that side to be the terminal side of our angle. Just as we talked about earlier, an angle has positive measure if the terminal side is rotated counterclockwise from the initial side, and a negative measure if the terminal side is rotated clockwise from the initial side. As a reminder, when we are in the coordinate plane, quadrant 1 is the upper right-hand one, and in quadrant 1, your angles are going to be between 0 and 90. Quadrant 2 is the upper left. Angles there are between 90 degrees and 180 degrees. Quadrant number 3 is the lower left. There, your angles are between 180 degrees and 270 degrees. And then quadrant number 4 is the lower right, with angles between 270 and 360 degrees. Now note, you see that 0 degrees, 90, 180, and 270 are not included in any of the quadrants. That's because we call those quadrantal angles. Angles whose terminal side lies on either the x-axis or the y-axis are considered to be quadrantal angles. Example number 3 here wants us to draw an angle with a given measure in standard position and state which quadrant it lies in. The first one, it says to draw an angle that's 100 degrees. Our angles are always going to start on the positive x-axis. So we draw our initial side here on the positive x-axis, and then we're going to rotate in a counterclockwise direction. And if we were to go to the positive y-axis, that's 90 degrees. We want 100 degrees, so it's slightly past 90 degrees. And there would be our 100-degree angle. And the terminal side here lies in quadrant number 2. B is an angle of 405 degrees. 405 degrees is more than 360. That tells us that our angle rotates more than one full rotation. It starts on the positive x-axis and it rotates one rotation in the counterclockwise direction. That's 360 degrees. And then it keeps going. It keeps going another 45 degrees. And so it ends here in quadrant number 1. So that angle is 405 degrees. Negative angles are the same as positive angles, they just rotate in the opposite direction. So an angle of a negative 120 degrees will start here on the positive x-axis, And instead of rotating counterclockwise, it's going to rotate clockwise. And so through quadrant number 4, that gets us to 90 degrees. And then we have to go another 30 degrees. And therefore, this angle here would be negative 120 degrees. And the terminal side is in quadrant number 3. The last one here, negative 450 degrees. This angle starts on the positive x-axis, and it rotates in a clockwise direction. It's going to go one full rotation, that's negative 360 degrees. And then it goes another 90 degrees, since 360 plus 90 gives us 450. Therefore, it ends here on the negative y-axis. It doesn't end in a quadrant. Therefore, we would say that this is a quadrantal angle. The last concept we're going to talk about in this first section is coterminal angles. Angles are said to be coterminal if they are two angles in standard position who share a terminal side. So the key thing here is they have to be in standard position and they have to share a terminal side. The easiest way to describe them is that measures of coterminal angles are going to differ by a multiple of 360 degrees. So for example, the angle in part D up here, which was negative 450 degrees, that would be coterminal with negative 90 degrees, since negative 90 degree angle also ends on the negative y-axis. We could say it's also coterminal with positive 270 degrees, since a 270 degree angle would start on the positive x-axis, rotate counterclockwise, and end on the negative y-axis. So in order to find coterminal angles, all you have to do is either add or subtract some multiple of 360 degrees. So example number 4 here says to find two positive angles and two negative angles that are coterminal with 130 degrees. We're going to take 130 degrees and add 360 degrees. That gives us 490. 490 degrees is coterminal with 130. We could add any multiple of 360. So for example, we could add 4 times 360 degrees to 130 degrees. That gives us 1,570 degrees. That is just another angle that is coterminal to 130. Then we could subtract from 130 degrees. If we took 130 and subtracted 360 degrees, we end up with negative 230 degrees. So that angle, the the initial side and the terminal side are exactly the same as a 130 degree angle. They just differ by one rotation and the direction of the rotation. Or 130 degrees minus 2 times 360 degrees. This number here can be any number. That's the number of rotations that you are going either in the negative direction or the positive direction. And this ends up being negative 590 degrees. So all 4 of those are coterminal with 130 degrees. And there are an infinite number of angles that are coterminal with any given angle. Sometimes the question will ask you to find the least positive. measure of an angle that is coterminal. We're going to do an example coterminal with 834 degrees. What that means is not only do you have to find the angle that is coterminal with it, you have to find the one that is the smallest value. Or in other words, you want to find the one that is between 0 and 360 degrees. Really, since this is a positive angle, all we have to do is subtract 360 until we get a value that is between 0 and 360. 834 degrees minus 360 degrees ends up being 474 degrees. And 474 degrees is still greater than 360, so we're going to subtract 360, and we get 114 degrees. 474 is coterminal with 834 degrees, but it is not the least positive angle. 114 degrees is the least positive one. Another example of this could be something such as the least positive angle coterminal with negative 236 degrees. Since this one's negative, we would have to add 360 to it. If we add 360 to negative 236, we end up with positive 124 degrees. That would be considered the least positive coterminal angle.